All right, hey everyone. We're going to be doing a lesson on factoring right now. So what we're going to do here is look at the different types of factoring that you're going to go and see in your algebra classes or your algebra 2 classes. And we're going to start with the very basics here. So let's talk about GCF factoring. This should always be the first thing you check, okay? And that stands for, again, the greatest common factor. So no matter what, this is the first thing we look for, greatest common factor. So let's take a look at an example of this type of factoring, the GCF here. So let's say, for example, I had something like 6a squared b minus, I don't know, we'll say 8ab. All right. Well, the greatest common factor is going to be the greatest amount of things that they have in common. So if I have 6 and 8, I'm going to think, what number goes into 6 and 8? What's the greatest number that both those numbers can be divided by? And the greatest would be 2. All right. A squared and a. Okay. The greatest amount of a's that they have in common is just 1a, because they both have 1a in it. And they also both have a b. So I have a b here. So once you get your GCF, we write down the GCF, we put an open parentheses, and we divide each of them by 2ab. So you divide by your GCF, and you write what's left over. So 6 divided by 2 would be 3. A squared divided by a would just be 1a. And b divided by b is just 1, so we don't need to put that down. Bring down the minus sign here. 8 divided by 2 is 4. A divided by a is 1. B divided by b is 1. We don't need that. This would be our answer for GCF. All right, the next type of factoring we're going to talk about here is called dots. Okay. And dots, that's going to stand for difference of two squares. All right. So the way that this is going to work is, first off, difference means it has to be subtraction. So let's take a look at a problem like this. Maybe x squared minus 64. Okay, so difference is subtraction. So must have subtraction, can't do it with addition. And we must have two squares here, or two numbers that we could take the square root of. The way that we do this, we form this double bubble. Okay, square root of x squared is just x. We put that in the first spot for each one of these. Square root of 64 is 8. And for the difference of two squares, we're putting 1 plus and 1 minus. And that's it, okay? So you just take the square root of each term there, and 1 plus, 1 minus, fill it into your double bubble. And there's going to be our answer, okay? And the reason why all this works, even with the GCF, is because this is just a multiplication problem. When you multiply this back through, you'd get back to the original expression that we had here. Same thing with this. If I multiply this out, I'll get back to the original expression, which is that x squared minus 64. But that's all you have to know for dots. The third type of method, or the third method I want to talk about here, is going to be a trinomial. Okay, and we're going to do a trinomial when the first term a is 1. Okay. I call this the AM method. All right, here's what it's going to look like. So a trinomial, we're going to have something like x squared minus 7x plus 10. Okay, we have 3 terms there, and the a term, meaning the number in front, is just 1. So if it's just 1 in front, here's all you're going to do. You form your double bubble. We take the square root of the first term. Square root of x squared is just x. We put that down. And then we do the AM part of this. We need two numbers that add to -7 but multiply to a positive 10. So they're going to have to add to negative 7, and they have to multiply to a positive 10. Well, the way that we're going to get that here is negative 5 and negative 2. Because negative 5 times negative 2 is a positive 10, but negative 5 plus negative 2 gives us negative 7 there. And that's how we factor down these trinomials. Now, the fourth method we're going to talk about is these tricky trinomials here. And that's going to be when your a term is greater than 1. So tricky trinomials when a is greater than 1. All right. I also call this the seal method. Okay. And I don't think anyone else calls this the seal method besides myself, but it helps me to remember what to do here. It's helped a lot of my students remember. It's really silly, but you'll understand why I call it the seal method in a little bit here. So let's take a look at an example of this. So let's say we had something like 3x squared, let's do minus 7x minus 6. And I want to factor this down. So our a value here is greater than 1. So that's when we're going to use this method. So what you're going to do here is you're going to take your a term and you're going to multiply it with your c term there. So 3 times negative 6 would give us negative 18. Now, just like the last problem, now we're going to do the AM part of this, but we're going to look for two numbers that add to negative 7, but multiply to negative 18. All right, well, that would be a negative 9 and a positive 2, because negative 9 times positive 2 is negative 18. Negative 9 plus 2 would give us that negative 7 there. So once we do this, I'm going to split that negative 7x up into negative 9x plus 2x. Because negative 9x plus 2x, that is 7x. We're not changing the problem here. And then I'm going to bring down the other two terms. So the 3x squared and the minus 6. Okay, so now we have this here. And then all we need to do is factor this by grouping. So probably should have talked about that first. But we're going to learn how to factor this, finish this by factoring by grouping. So what we do is we group the first two terms together. We group the second two terms together here. And we factor out a GCF. Now I do want to explain, why do I call this the seal method? Well, the reason why I call this the seal method here is because I imagine this as two eyes, the nose of the seal, and then this is like the water down here, so it looks like the seal is kind of starting to stick its head above the water. I don't know. That kind of helps me. I don't know if you guys can see that here, but that's why I call it the seal method. Okay, now getting back to this and how we're going to approach it. So we're going to factor out the GCF. So from these two here, the GCF of the first part is going to be 3x. So again, then we imagine like we're dividing each one of those by 3x. So that's going to leave me then 3x squared divided by 3x is just x, minus 9x divided by 3x would just be 3. All right. And then we factor out the GCF from this. So I'm going to take out a positive 2. And then what's left over here, divide each of those by 2. 2x divided by 2 is just x. 6 divided by 2 would just be 3. So then I'm left with this right here. And now, to finish this out, I'm going to factor out a GCF from this term and this term. What do they both have in common? Well, you could see both of these have x minus 3 in them. So I can pull that out. So x minus 3, that's going to be my GCF. And then what's left over? Well, if I divide each of those by x minus 3, that leaves me with 3x from the first part and it leaves me with a positive 2 from the next part. So we'd get x minus 3 and 3x plus 2. Okay, so that's the tricky trinomial combined with the grouping method there. All right, the last kind that I want to talk about here, since we already did grouping within that, is going to be the cubing factoring. Okay. So let's say, for example, here we had something that looked like this. X cubed plus 27. This is also known as the SOAP method. Okay. The way that this works is we set up this double bubble, but the second bubble is going to be a little bit bigger. What SOAP stands for is the same sign. So since it's a plus here, I'm going to put a plus. The opposite sign, okay, so the opposite of a plus is a minus, and then always positive. So that's always positive. Now, since this is cubing, the way that we're going to do this here is you have to have two perfect cubes. Okay, so both of these I can take the cubed root of. The cubed root of x cubed is just x. The cubed root of 27 is just 3. And then all you do here is in the first spot, you square the first term. So x squared. In the last spot, you square the last term. 3 squared is 9. And in the middle, we multiply. So 3 times x, I'm just going to multiply these two together, and I put that right in the middle as 3x. So it'd be x plus 3 times x squared minus 3x plus 9. Okay, we also could see this with the minus sign here. If I had x cubed minus, let's say, like 64, well, then I do the same thing here. So SOAP, same sign, the opposite sign, always positive. Cubed root of x cubed is just x. Cubed root of 64 is 4. First term is the first term squared. Last term is the last term squared. So 4 squared is 16. The middle, I multiply those two for x. And there we go. And you've successfully factored with the cubing there. All right, so those are going to be your major factoring methods. I hope this helps. I kind of just wanted to give you guys a quick review. So this is just a refresher, not teaching it brand new here. Hopefully this is just bringing back what you've already learned in class. All right, if you guys have any other questions or if there's a video you want to see, make sure to leave it in the comments below. Have a good one, everyone.